The painting primaries, those three colors that can mix all the other colors in the world. You've probably learned what they are: red, yellow, and blue, right? Well, look at this while I'll tell you how you've been lied to. Just bring your screen closer to your eyes so that it covers your entire field of vision and stare at this white dot in the middle. Don't move your eyes. Whatever you do, stay focused on this point, and we're going to count to 15 seconds, and then I'm simply going to change to a white screen. When it happens, stay focused on the little dot and don't move your eyes for another couple seconds or you'll miss what's going to happen. Ready? So there you go. What you just saw is called an after image, and you've probably seen something like this. An after image is an image that continues to appear in the eyes after a period of exposure to the original image. Retinal fatigue causes the complementary colors to be seen in the after image. It inverts the colors, so it gives you a sort of a negative of the original colors. And that's the key here. After images are the complementary hue of the color. That's a given of our visual physiology, and it should be at the center of our color system. Unfortunately, the so-called three primaries, red, yellow, and blue, fail to account for this fact. So we can already say that they are not a reliable set of colors to build a color system from. So when you see a color wheel like this one, very famous wheel by Johannes Itten, you know it's wrong because it's built out of three primaries that are not accurate, not well placed, and not helpful for painting at all. It's all wrong, and yet it's still going strong. Most schools teach this stuff or a similar version of this stuff, and most art schools do as well, and they should be ashamed to not know any better because this set of three colors is not what you should base your color theory on. Have you ever wondered why the smart people who build printers have never thought about using red, yellow, and blue cartridges? Have you ever wondered why the smart people who have programmed Photoshop have never used the Johannes Itten color wheel in their program, simply because it's wrong? So then, if we don't start with red, yellow, and blue, what color should we base our color theory on? Cyan, magenta, and yellow maybe? Heck no. Cyan, magenta, and yellow is a better system than red, yellow, blue. But it's still not relevant for us painters because remember, we are painters here, not printers. And by the way, I just want to say I hate printers with a passion. How come they always need magenta when you just need to, print a black and white document? Anyway, as I was saying, all the stuff that doesn't help me paint in a color system, I leave it out of the equation. I leave it to the scientists. I couldn't care less. I just want the lies and the errors to stop in our art education. So I think that this red, yellow, blue system comes from a time when they didn't know any better, and for a while it was good, and they kept it for some reason because they like the idea of creating all the colors out of the three primaries. Sounds good. It's inaccurate, but it sounds good. And also because this color system is fine for mixing skin tones, which is what most people need. You don't always need to make vivid purples, for example. You don't necessarily always need to make vivid turquoises. So most of the time, red, yellow, and blue will work. And absolutely, they work perfectly fine. But here, I just want to say that I have nothing against the red, yellow, or blue colors. I love them. I use them. Nothing wrong about them. What I want to oppose is the notion of primary itself. That's where the lies are. That's where the errors are. Red, yellow, and blue are just colors, and they are perfectly fine as they are. What's really wrong is to try to base an entire color system out of these three, because they didn't ask for it. So according to the commonly accepted definition, colors are primary if they cannot be obtained by any mixing and if they allow to mix all the other colors. So first of all, it's wrong to say that primaries cannot be obtained by any mixing. For example, if I use a quinacridone violet and cadmium orange, you can get a red that's as chromatic as a so-called primary red on the red, yellow, blue model. If you use phthalo blue, PB15, and phthalo green, you can get a color that accurately matches the cyan primary in the cyan, magenta, yellow model. And I could go on like that forever. If you find the right pigments, you can always go from one to the next through mixing. Don't believe me? Check out this video where I do a color mixing exercise that will just blow your mind. It's all about changing any color into a different color, and at no point do I ever need the notion of primary. One super important notion is the notion of complementary, but we'll come back to it later. So hear me out. The notion of primary is useless for two reasons. One, it's not a valid foundation for a color mixing system, and two, it's not relevant practically for mixing and does nothing that any other set of pigments would do. So to fight against this nonsense, I came up with a practical mixing system for painters that doesn't have primaries, but 6 main colors. It's part of my complete color theory course that you can check out with the link in the description below, but I'm gonna give you the main idea here. See, color is a continuum, like an ocean that fluctuates, and what matters is that you know how to navigate it. This color system is not based on 3 primaries from which all the other colors would derive. It's simply based on our color vision. How many colors can we actually perceive? And we try to assemble in a set of wheels all the colors that our eyes can see. And we just try to arbitrarily organize them in a way that's useful for painters. What's useful for us is not to try to make everything out of 3 colors, but to have colors that harmoniously cover the widest possible spectrum. It doesn't matter how much we have. What matters is that we can find what color we need based on which area of the color spectrum we need to explore. So our main colors need to be placed all around our wheel in a balanced manner. As you can see, I placed my main colors so that they face their complement on the opposite side of the wheel. This is super important. This is the only reliable way to connect our color wheel to our vision. We can be pretty certain about these complementary pairs because they are based on the retinal persistence of our eyes, and they can be checked with the phenomenon of after image that we've seen at the beginning of the video. If you want to be sure, look at the dot again for 15 seconds and you'll see the accurate complementary pairs appear. Same thing, I'll now switch to a white screen, but you need to keep your eye centered on the dot and don't move. So there you go. So from this to this, see how the colors switch, invert places? It's because they are complementary. They are antagonistic. One color is made out of everything that lacks in the other colors. They are complementary. And in case you were wondering, this is not an effect of the screen. You can do the same experiment with paint on a white surface, and I can assure you that you'll see the same thing. The phenomenon of visual persistence is an effect of our visual system. It should be noted that these pairs that we see here do not work in a model where red, blue, and yellow are supposed primary colors. In this one, the supposedly complementary pairs would be red-green, yellow-purple, and orange-blue, and they do not match the observations. So what the red-yellow-blue model gave us was completely inaccurate. On a screen or with real paint on a white canvas, here are the real complementary pairs that we get. Red is complementary to cyan, yellow is complementary to blue, and magenta is complementary to green. And this is the only thing that can help us connect our arbitrary color placement with something grounded in our human vision. We just have to place them at equal distances around the color wheel and try to organize the other shades around them, and voila. Oh, there's just a tiny thing here. I pushed yellow to 80 degrees instead of 60 degrees to make more room for this very useful warm range that's key for skin tones, notably. Actually, a lot of things in nature have this kind of range of colors, so I chose to put yellow a little bit further from red, adding orange in the process to get closer to human perception. This avoids green to dominate too much because nobody needs that much green on a color wheel, but everybody needs a wide variety of brown and orange. Alright, so I'm not gonna spend an entire episode just exploring this color wheel because it would just take forever. But I just want to point out how irrelevant the notion of primary is in this case, and how central another notion is, the notion of complementary. So let's talk about it. Let's talk about complementaries because I think that this is actually a key notion that actually matters, and it doesn't work if you think that red, yellow, and blue are primary colors, because if you have these at the center of your color system, then you have the wrong complementaries, and if you have the wrong complementaries, you can't make all the amazing things that complementary colors can make. So what are complementary colors? By definition, two complementary colors are antagonistic, so one is composed of all the nuances in the spectrum that are missing from the other. Theoretically, the mix of two complementary colors gives a neutral gray. Look at what happens when you add the spectrum of cadmium red and cobalt teal blue. The result is an almost entirely straight line. It means that it is composed of the same proportion of all shades. It's neither red, nor yellow, nor blue, nor green. So in short, it's a neutral gray. But we must draw a line here between visual complements and pigmentary complements. The visual complements are based on the physiology of our visual system, and the pigmentary complements are based on the paints that we actually use. So visual complements and pigment complements are significantly different. When two complementary pigments are mixed gradually, the result is not necessarily going to be a straight line passing through the center of the wheel. Quite often, rather than a straight line, the pigments will form an arc, and depending on the nature of the two pigments and their tinting strength, lots of factors, the arc can be more or less curved. Thus, yellow ochre, for example, and ultramarine blue form an arc that bends slightly towards green, while cadmium red and cobalt turquoise will form an almost straight line. So everything pigment related is quite chaotic. Not only is the color wheel a simplification, keep that in mind, but pigments also have behaviors that make their mixtures unpredictable. We cannot simply start from two visual complements in a color wheel and accurately predict the result of a paint mix. But we can still make a neutral gray using the theory of the complementary colors, and it shows that this color system actually works. So what I suggest is that you think about bows. You aim for the most neutral color possible by starting from two colors opposite on the wheel. If the mixture of these pigments has a bow shape, you then find a pigment on the other side to pull on the string. For example, again, yellow ochre and ultramarine blue form a bow that's slightly curved towards green, so I can adjust this with a pigment opposed to the green. So the complement of green is magenta. So by adding a very small amount of quinacridone rose, I can adjust the hue and get closer to a neutral gray. As the curve tends towards green, it must be adjusted with magenta. If it was towards red, we would adjust it with cyan, and so on. You always adjust a color with a complementary pair if you want to make it pull towards the gray in the center. So if you find that the theory of the complementary pairs doesn't work with your pigments, it's because you need to always adjust with a third color, because the complementary pigments never mix exactly how the complementary colors suggest. So always adjust with a third color. And this is what I call navigating the color space. Navigating the color space. This is what you need. You don't need the notion of primary. What you need is an accurate and practical color wheel system that will let you start at point A and get to point B, even if the road is not a straight line, because we're smart. We know how to navigate this color space. And by the way, my color system is not necessarily a true color wheel. It's just as arbitrary as any other color theory in the world. But it tries to be helpful and practical for painters. So if you want to check out a great color mixing exercise to get started navigating this color wheel, watch this video next, and I'll see you for the next one, my friend. As always, joy and inspiration to you. Bye.